Hi guys, I want to just tell you a little bit about this data here and help explain the experiment that underlies all of this data that we see on this data table. So if we think about the scientific method, whether it's in our chemistry class or it's in animal behavior, it always follows a predictable pattern, okay? And so far in this class, we spent time doing observation as an animal behaviorist. That's what the ethograms were. We've learned how to ask questions and make predictions or hypotheses. And what we're going to focus on now really is on experimentation, analysis, and conclusion writing. Okay, so we're going to start by looking at the data that another scientist collected as a result of experimentation. And then that's going to lead us into your own data collection of an experiment that you'll watch as part of a video about minnows. So we're going to look at some data, not about minnows, but about seagulls. And we looked at this data last week a little bit, but I want to help explain exactly what's going on in the data so that you can use it to analyze the information a little bit and maybe draw some conclusions. So in this experiment, Nicholas Tinbergen, one of the fathers of the process of studying animal behaviors. He was one of the scientists that kind of developed the structure for how we analyze animal behavior. He studied birds a lot, right? Which is why we use birds a lot in some of our introductory work this year so far, this trimester so far. And one of the birds he studied were these seagulls. And we watched last week seagulls begging at the beaks of their parents, and we saw the baby seagull pecking at its parent's beak. And so Tinbergen wanted to investigate that behavior, the behavior of the baby seagull pecking at its mother's beak or begging. So he calculated or collected data on the pecking rate. He observed the behavior, pecking, at its mother's beak, and he counted how often it was pecking. And he counted it first with a natural head. So the data on this table here, the natural head was him sitting there with watching a real baby pecking at its actual parent, right? And he counted how many times did the baby seagull peck at its parent's beak, and that's the natural head data. And then he said to himself, well, I want to investigate what causes that baby bird to peck at its mother's beak. He wasn't satisfied with the explanation that, like, oh, it's its mother, that's why it's pecking at it, right? He wanted to understand exactly what set it off, because he knew from some of his studies of fixed action patterns that the cause of a behavior is sometimes not obvious, or it's very simple, right? A fixed action pattern, you don't need to see your egg to roll it back into the nest. You just need to see an object that's about egg size laying next to your nest. That's all you need. So he kind of wondered, is it the same with the seagulls? So he built a model, and that's what the standard model is. He just built literally a puppet head of a seagull, and he put it in front of a baby seagull, and he counted how often it pecked at it. And sure enough, even though it wasn't a real seagull, the baby pecked at the standard model even a little bit more than it pecked at the natural head. But essentially the data was equal, right? So then he just went through a whole series of different experiments. So if we think of the scientific method, he kind of had the same question, right? And he was predicting that there were going to be causes, but he made a series of predictions. Like he said, well, I predict that having a bill is the cause of the behavior. And then he did an experiment. Or I predict that having a head is the cause of the seagull pecking. That was his prediction, and then he did an experiment. Or I predict that having a spot is the cause of... And so he essentially did a whole bunch of individual predictions, and he broke the head of the seagull down into its parts, and he tested each one separately. So he had a bunch of different hypotheses, ran a bunch of different experiments, and now we're looking at all the data from all the experiments. And so what did he find? Well, he found that sometimes when he removed pieces of this model, this puppet that he had, it changed the behavior. And sure enough, the seagull didn't peck at the puppet as often, right? And then other times he would remove something and nothing happened. The baby seagull continued to peck just as normal. So how do we analyze this, right? Well, if our question is, or if the question that he was asking in this experiment is, what is the cause of seagull begging behavior? we cannot say that it's its mother, right? The mother is not the cause because a puppet works just as well as the mother. So is its mother the cause of the behavior? No. So there we have an answer to a question. We've analyzed the data. What about having a bill? Think about that for a second. Is that the cause? He took the bill away, and what happened to pecking? Well, pecking went way down. Baby still pecked a little bit, but very little. So does having a beak cause the behavior or a bill? He would have said yes. I would say yes, right? Because by removing the bill, the behavior goes away. That means the bill matters. So then he kind of asked the opposite question. Well, what about the head? What if it's just a bill? And so he removed the head and he kept the bill. And sure enough, he got about the same amount of pecking as he did when there was a head, as he did when there was its actual mother. And so now he starts to have a bit of an answer to his question, that perhaps it's not the mother, it's not even the head, it's the bill that's the cause, right? And he actually made a kind of a supernormal stimuli, if you remember from last week. He took and made like a really like exaggerated bill, a very big bill with lots of dots on it. And sure enough, just as you'd expect with supernormal stimuli, the behavior increased significantly. Not significantly, but it increased, right? The baby bird pecked at a stick with dots more than it would peck at even its own mother, or even a model that looked like a seagull, right? This thing doesn't look like a seagull at all, and yet it pecked at it more. So here's what I'm going to ask you to consider. He did a bunch more experiments here, right? So he first started off by building a standard model and then a head, but then he kept manipulating that model, and he tried a few other things. Right? He tried removing the spot entirely or not moving the head. That one's a little weird. If you look here, you'll notice that he's got this directional arrow showing the way that he was moving the head. And if you noticed in the video last week of the seagulls, you would have noticed that the mother bird was always kind of bobbing her head up and down. So he asked, well, does the movement matter? Is that part of the cause? You know, he had moved the bill and the stick. And part of good experimentation, guys, is not changing everything at once. So when he took the bill away or the beak away, he kept moving the head in a natural pattern, right? And then later on, when he wanted to just test movement, he kept the whole head in there, right? And removed the movement only, right? Kept the dot in the right place and everything in the right place and tested movement. Okay, so I'd like you to look at some of the other things he did. He tried changing the direction of the movement of the head. This thing called a cock's head, which I understand is kind of a funny name. That just describes a rooster. He like completely changed the shape of the head. So it still had a head, but it was shaped like a rooster instead of a seagull. He changed the color entirely of the head. He put the spot in a different place. He moved the spot and recorded what happened. So you're going to analyze some of his other research now to get some practice in how to analyze data to see if it matters. Because then you're going to be asked to collect data and do the same thing with your minnows. Okay? There we go.